Hi again, guys. Another problem to the equilibrium. It says here the 30 kilogram pipe is supported by A here, and a system of 5 chords 1, 2, 3, 4, 5. Determine each force in the chords for equilibrium. The first thing that you should do is convert those 30 kilograms of mass. Well, it's not the first thing. You can do it at the end. You can work everything in kilograms, but always remember at the end to convert it. So how do we convert that? We multiply that by G, 9.81, and we get a force over there, 9.81 times 30, 294.3 Newton, 294.3 Newton. That will be the force. And now we start doing free body equilibrium, particle free body equilibrium. Remember, if you're working with a particle, you have, and 2D, you have basically two equations that you can use. Summation of forces in x equals 0, and summation of forces in y equals 0. And I must say, like I always say, it doesn't have to be x and y, it's in any two known collinear axes. That's what you have to do here. So if you select the particle H, basically what you have is a wave of 294.3 Newton, and you have a tension H here, which if you do summation of forces in Y, TH has to be equal to 294.3 Newton. Perfect. It's obvious, right? You don't even have to do that. If this is the weight, this is the tension, and this will be the same tension as here. Now we check the next joint. Can we go here, for example, and do equilibrium here? Not really, because we have three unknowns. Now, can we go to the joint A? How many unknowns do we have? Our unknowns will be the tension AE and the tension BA. So let's do a free body diagram of the particle A. Right here, we have a tension AE going in this direction, a tension AB going in this direction, and a tension TH, which is this one, coming in this direction of 294.3 Newton. Now, silly question. Super silly question. Why did I say tension going in this direction and tension going in that direction? Couldn't be the tension entering into the particle A? Why did I immediately assume that it was like that? And the answer is very simple. You can come with any type of answer that you want to, but these are cables. And the cables do not push. So they have to be always in tension, and that's why they have to come, and they are always have to come uh, out of the particle, out of the particle. That's what happens there. Now the next step here is doing summation of forces in X, summation of forces in Y. Really quick, in your mind, do a count. How many unknowns do I have in the X direction? One, and the horizontal component of AB, two unknowns. How many unknowns do I have in the Y direction? Only one. So it's worth it to start with doing summation of forces in Y equals 0. And if we do that, then we have the, here's my marker, somebody stole it here. That is a component of AB going in the Y direction, which will be AB sine 60, and this is the other component, the other force in the Y direction, 294.3. And if I want to find AB, the only thing that I have to do is pass this to the other side, 294.3, and divided by sine 60. 294.3 divided by sine 60, and then you get 339.83. 339.83 Newton. Perfect. Now we can do in the same particle summation of forces in X, because I already know this value here. So if I do summation of forces in X equals 0 for that particle, you get the X component of AB will be that one, times, that will be AB cosine of 60, because it's adjacent and it's going to the left. That means it's negative. Negative AB cosine 60 plus AE equal 0. Or if I pass this to the other side and solve for AE, so AE will be AB cosine 60, but I know already AB, so AE will be 339.83 cosine 60, which is just sine 30.5. Oh, what am I doing? Times 339.82833684. That would be 169.91. For those of you that are wondering, oh, how did he get those numbers over there? If he copy here 339.83, because I have the problem here, the question here, the answer here from the previous step. So I don't like using round up, round down numbers when I'm calculating something. I use the rounding just for the final answer, like this one here. But if I can keep the whole number, I will keep the whole number. So now we have this tension, and this tension. Now we can move to particle B. So if we move to particle B, which is that one, um, I have, let me put the particle B here. I have this, which is BD. And I have this little triangle, which I know you like. At least I do. I hope you do. And then I have this tension, which is BC. And then I have this tension. Remember, it was AB in this direction. But when I move to the other side, it has to come in this direction for equilibrium. So I have the force coming in this direction. And I know this angle is 60 degrees. And this value is the value for tension AB, 339.83 Newton. Now, how many equations? Two. Summation of forces in X, summation of forces in Y. Once again, if I go in the X direction, I have this component and this component, two unknowns. I'm not going to be able to solve it at once. But if I go in the Y direction, the only component unknown that I have is basically this one. BD, this component of BD. How much is that component of BD? You take this number, 3, in the same direction, right? Divided by 5, multiplied by BD. So 3 over 5 BD, and it's going up, it's positive, and then the other force involved into the summation of forces in Y will be this component for this force, and that will be minus, because it's pointing down, 339.83 cosine, no, sine, because this is the angle, so sine 60 equals 0. And we can solve for BD, which will be 339, this is the value, 339.83 in the other side, of course, times sine 60 multiplied by 5 and divided by 3. And that will be 490.5 Newton. Last but not least, now we need to calculate BD. How do we calculate BD? By doing summation of forces in X equals 0. So this value, I already know it, is 490.5 Newton. Let's do the summation of forces in Y. In X, negative BC. Why negative? Because it goes in the negative direction, to the left. Plus this component of BD. How much is this component of BD? This triangle, this is 4. 4 divided by 5 times the value of BD, which is 490.5. and it's positive because goes to the right. Now we have this component of this force, which is the same as this component. So we can use cosine 60 degrees, positive 339.83, cosine 60 degrees, and that has to be equal to 0. And from here, I can pass BD to the other side and say that BD is going to be equal to 490.5, I have it here, times 4 divided by 5, plus 339.83 cosine 60. And I get syntax error, and that will be the answer that we are looking for. Yay! Cosine 60, cosine 60, cosine 60. 562.315. 562.315 Newton. And those will be our 5 forces. 1, 2, 3, 4, 5. Problem completed. Now, I know this is particle equilibrium, but let's try a different approach if you are really in a rush to do this problem. Let's say that we already advanced in time and you already know something about rigid body equilibrium. Not only particle equilibrium, but rigid body equilibrium. And let's say that the problem is only asking you to find the value of this tension here. Then look what you can do. Instead of doing equilibrium along a particle, and you're going to do this diagram, this rigid body equilibrium diagram, and then you will have something like this. Don't worry too much if you don't understand what I'm saying right now. I'm just explaining you this because probably in the future you're not going to have these type of problems. That will be B, that will be A, and remember you have here the beautiful triangle 3, 4, 5, and this will be BD, and this is BC. Now this weight is this weight, and we know that weight. We calculated that weight, and we say that it was 294.3. So 294.3. That's, remember, that's the 30 kilograms times 9.81, and this force is AE. Now, obviously, we are now in rigid body equilibrium, and we have more than 2 equations. We have 3 equations: summation of forces in X, summation of forces in Y, and summation of moments, which is something that we start covering in chapter 5. But it doesn't matter, chapter 4, chapter 5. Let's only talk about summation of forces. If I do in this system summation of forces in Y equals 0, the Y component of this one will be BD multiplied by 3/5. So then will be 3/5 multiplied by BD positive minus 294.3, meaning I can solve immediately for BD, and BD will be 294.3 times 5 divided by 3, 490.5 Newton, which is the value that we got before. Look, this is the value that we got before after doing all of these instead of just doing that. Of course, as I told you, I'm just going ahead of the material. And then you can ask me, how are you going to find this, or how are you going to find that? That's another story. But if you want to find now the rest, and you already know this, you can do particle equilibrium here and find this and find that if you want to. But if the problem was asking only for this one, look how easy you could do that by knowing rigid body equilibrium, which is called, and we do a free body diagram of that. Don't worry too much if you don't understand this right now, but as soon as you hit chapter 4, chapter 5, go back and check what I did here, because probably you're going to be using that or you should be using that in the future. Have a good day, guys. Thank you for watching.